Yes, hi everyone. Good morning. So today we are going to start with another supervised machine learning classification model that is known as naive bias. That is known as naive bias. So the word naive over here, what do you mean by naive, everyone? What's the meaning of naive over here? What do you mean by naive? Naive means a person without enough experience, right? So we can call it as inexperienced, right? Inexperienced. So, or amateur, we can say. So this particular model is also naive. We'll see why it is called as naive, right? So it's another type of supervised classification model, and naive bias is a probabilistic classifier which returns the probability of a test point belonging to a class rather than the label of the test point, right? So now, excuse me, just yeah, in this session, you will learn about the Bayes theorem in probability and its building block. You'll be learning about conditional probability. What do you mean by conditional probability? And finally, we'll learn about the Bayes theorem, right? So let us start with this. So, uh, you guys already know what is probability. Let us start our discussion from the probability concept. What is probability? What do you mean by probability? Yes, what is probability?
Chances of an event occurring.
Yes, what is probability? Chances of the event occurring. Okay. So can I say favorable outcomes divided by total outcomes? So for an example, if I toss a coin, probability of head is 1 by 2, right? That is 0.5, right? Now, let's say uh, we have given probability of play, which is 20 by 30, which is 0.66. Means 20 out of 30 times play or game is possible given the weather condition, right? That is a probability, another probability that we have given. Now, the probability of play, probability of play given rain, given rain is, let's say, 1 by 10. That is 0.1%. Means only 1 times out of 10 game is possible. Game is possible given the condition of, given the chances of rain, right? When there is a rain, only 1 out of 10 times the game or play is possible, right? Now we are trying to understand a condition here. So that's why we will give heading as conditional probability, right? Our heading is conditional probability. So there is some condition, right? There is some condition, like probability of event occur given some condition, that is known as conditional probability. Probability of certain event occurs given some condition. So let us take another example. Example number 2. You have given probability of spam, that is email classification. Very famous example, email classification. Probability of spam is 1 by 5. That becomes your 0.2, right? That is 20%. And probability of given email is ham, means not a spam, is what it will be? It will be 4 by 5. So it will be 0.8, that is 80%. Now you have to find a probability of spam given the word in that email is equals to, let's say, Viagra, right? So the moment you read this word in your email, suppose you got email consisting this word, you get an idea about this word is this particular email is a spam. Yes or no? So the moment you read this word, the probability of the mail or of this mail considered as a spam increases. Yes or no? Probability of this mail considered as a spam increases. So it increases to 70%. Let's say this is 70%, right? Earlier probability of spam is only 20%, but given the word is this, your probability increased to 70%. So that is known as conditional probability. We have to find probability of a spam, email is spam, given the condition that word Viagra is in that particular email, right? So no, so now you have understood the intuition behind conditional probability. We'll just elaborate the notion of this kind of probability more formally, right? We'll just elaborate the notion of this kind of probability more formally. So let's say you are trying to understand prior. There is one concept known as prior, and there is one thing known as posterior. Prior means before. Prior means before. Posterior means after, right? So let us try to see this. So you have been given prior and posterior probabilities. So let's say probability of play is 66%, and probability of spam is is let's say is 20%. It's already been given to you, right? Now you have to find probability of play given the condition is rain, or probability of spam given the condition word is equals to Viagra, right? Suppose in your email you got email something like this, in that word is equals to meeting at 10 o'clock, something like that. So the probability of given email being spam reduces, right? It will be 5%. Earlier probability of spam was 20%. But the moment you got this word and you're finding conditional probability, whether the word is being meeting at 10 o'clock, something like that, your probability increases, right? Now, similarly, this posterior, this one, earlier probability of play is 66%. But the moment you hear or you read this word probability of play, given the rain is there, your probability decreases to 10%. Earlier it was 66, it is decreased to 10%. Similarly, here probability of spam was 20%. But the moment we just got this word and we are finding the conditional probability of spam given the word is Viagra, it will increase to 70%. Yes or no? It will increase to 70%. So that's what it is. That is your entire conditional probability. Now, can you guys think about such examples of prior and posterior? Can you guys think about such examples? You just have to form example, that's all. Yes, everyone. What are the different examples that you can come across with your day-to-day life? Yes, guys. Now, suppose consider A and B are events. A is probability of an email being spam, and probability of B is probability of the word being Viagra. Probability of the word being Viagra. Now, probability of A will become, suppose it is 20%, let's say. And you have to find probability of A given B. That is 70%, let's say. So we have Bayes theorem. We have Bayes theorem, which will calculate this conditional probability. We'll see that. How do you calculate this conditional probability, right? So why do you think there is a need of conditional probability? Why there is a need of conditional probability? Why there is a need of conditional probability then? Because sometimes, not sometimes, most of the times, what happens is we are in a such type of situation where we are interested to find the conditional probability. Let's say probability of win if I win the toss, right? Probability of win if I win the toss, or probability of uh, Virat scoring century when we bat first. There can be n number of conditional probability, right? So conditional probability is needed to understand the relative probabilities, which is more often the case in the real world scenario, instead of looking into the absolute probability of the events in isolation. Real time scenario, real time scenario, we have conditional probabilities, right? In real time scenario, We have conditional probabilities. Probabilities. Right? So let us go to the next part now. Now let us try to understand Bayes' theorem. Now it's perfect time for us to understand how do we find the conditional probability. So I'll put a heading, and this is theoretical part uh, for calculating conditional probability. The example we will now use is something almost all of us can relate to, which is cricket. While watching cricket, means on TV, you may have seen statistics similar to India wins 70% matches, 70% matches when Sachin scores a century, right? It sounds like conditional probability, right? This is a classic example of how conditional probability can be used to estimate the chances of an event taking place, given certain other events that have happened, right? So suppose India plays 400, suppose 100 matches. India play 100 matches, out of which we win 60 matches and we lose 40 matches, right? And suppose Tendulkar, or let's say Sachin, he also plays this 100 matches, scores century in, scores century in 12 of them, and doesn't score century in 88 of them, right? To make this interesting, you also have this additional information. Out of the 60 games that India wins, out of this 60 games that India wins, Sachin scores century in 10 out of them, and out of 40, India lose. India loses. Sachin scores a century in only two of them, right? So let us look at how two-way contingency table or matrix will look like. So let us create a table or matrix. So here, what I'll do is I'll write down India win, India lose, total. Here I'll write down Sachin scores a century. Here I'll write down Sachin doesn't score a century. And here I'll write down total. Right? Let us expand this little bit. Let us expand this little bit. Let us expand this little bit. Okay. Now, uh, we have data. Sachin scores century, India win 10, right? India lose 2. Total is 12. Sachin doesn't score a century. India win 50 out of them. India lose 38 out of them. Total is 38. And total of India win is 60, as you can see over here. This is 60. Total of India lose is 40. So 2 plus 38 is 40. And total played is 100. Right? So let's create this table. Okay. Now, can you answer this questions? This question, only one question. Like, what is the probability of India wins given that Sachin has scored a century? I'll give you 2 or 3 minutes of time. You have to find the probability of India wins given that Sachin scored a century. Yes, what's your answer? 0.833. Okay, let us start working on this question. Let's say A event is India win and B event is Sachin's century, right? So the probability of A that India wins, we have this which is 60 out of 100. So 60 by 100. And probability of B, that is Sachin scores century, is 12 out of 100. Right? Now we have to find the conditional probability of A given B. The probability of India win given that Sachin scores century. Right? So what we'll do now is we will try to find Sachin scores century is and India win is 10 out of 12. It's already given over here, right? 10 out of 12. Now, uh, whether I can write down probability of A comma B is equals to probability of India win and Sachin's century, right? So there's one concept of intersection, probability of A. Consider this as intersection. Now we don't have a symbol for this. Let us define the symbol of intersection as this one, A intersection B. So that is 10 out of 100. 10 out of 100, Sachin scores century and India. I mean, both common, like Sachin score in century and India win. Intersection means common, right? So it is 10 out of 100, right? This 10 out of 100. So whether both the condition is satisfying, India win, Sachin score century, it is 10 out of 100, which is exactly equals to probability of B intersection A, because we already have studied in our school level that probability of A intersection B is equals to probability of B intersection A. That is your probability of India win and Sachin score century. That is also 10 out of 100. So 10 out of 100, right? Now, the conditional probability which you have calculated, this is as 10 by 12, which we actually calculated by this two formula, probability of A intersection B, probability of A intersection B, uh, divided by probability of B. So that becomes 10 out of 100 divided by 12 out of 100. So I can write down probability of A intersection B is equals to probability of A given B into probability of B, right? Probability of A. Now let us keep this aside over here. Let's focus on this thing only. Probability of A intersection B is equals to, I can move this to left hand side. So it becomes probability of A given B into probability of B, right? And we already know the probability of B, that is uh, Sachin score century, which is 12 out of 100. So we'll write down probability of B is equals to 12 up, or till 12 by 100. And we'll write down uh, probability of A given B, which is 10 by 12, and which becomes 10 out of 100. The probability of A intersection B we have calculated over here, which is 10 out of 100. So this becomes your formula. Which one? This one. This is your formula for conditional probability. And this is what is important for us, right? So you should remember this formula, that probability of A uh, intersection B uh, probability of A intersection B is equals to probability of A given B into probability of B, right? Probability of B. So that's what we have. And likewise, you can solve any conditional probability where you should know uh, any two terms, probability of A intersection B and probability of B, right? You can create contingency table, but that is very lengthy procedure. So that's what we have. Now I can use another formula for probability of A intersection B, that is reverse probability of B given A into probability of A, probability of A, right? It is same. Probability of B given A uh, will be exactly equals to B given A means Sachin score century given that India win. Sachin score century given that no B no Sachin century given that India win. Ah, Sachin century given that India win, it becomes 10 out of 60, right? So this becomes 10 out of 60 into probability of A you already know, that is 60 by 100, 60 by 100, and which becomes 10 by 100, right? So probability of A intersection B is also calculated by this formula, that is probability of B given A into probability of A. So it can be this or it can be this. So I can write down over here probability of A given B into probability of B is equals to probability of A intersection B, right? So that's your conditional probability, or that is a Bayes theorem. So this thing is known as Bayes theorem. The formula is probability of A given B is equals to probability of B given A into probability of A divided by probability of B. So you just equate this. Suppose you want to find probability of A given B in this. This is equals, right? So probability of A given B is equals to probability of B given A into probability of A, and this will be divided by this one. So probability of B. That is your Bayes theorem for you. Now, is this thing clear to you? What is Bayes theorem? Yes, guys. Now let us take one another interesting example. Uh, Suppose example A. Let's revise the concept that you have just learned using spam and ham example. Let's define two events A and B. A is the email is spam. A is the email is spam. B is the email contains the word Viagra. And now, based on the above definition, so we have to solve the questions given below. First question: what is the probability that an email okay, just type what type of probability that an email which contains the word Viagra is a spam? What type of probability that an email which contains the word Viagra is spam? So it's a conditional probability. It's a conditional probability. Second now, what type of probability is the probability that an email contains the word Viagra and it is spam? That email contains the word Viagra and it is spam. What type of probability it is? So it is a joint probability. And conditional probability symbol, how do you write down conditional probability symbol? It is probability of A given B. You write down this, right? And what is the symbolic notation of joint probability? So joint is nothing but intersection. It's an intersection. So probability of A intersection B, that is your joint probability, right? Now that's what we have. Uh, so in this way, we have understood the theoretical concept of Bayes theorem, its building block, that is conditional probability and joint probability. You also understood how Bayes theorem can be derived using joint and conditional probability using two-way contingency table. That is this. This is two-way contingency table. And now in the next part, we will understand how naive Bayes works with the categorical data and different terms associated with naive Bayes. Right? So let us take one example and solve this. Uh, Understand the naive Bayes. So I'll create a table courses and I'll create here male, female, and total. Courses is it should be big because in that we are going to add data science, that is DS, data science, that is DS. Here we'll add machine learning, that is ML. Then we'll add another thing, that is deep learning, that is DL. We'll add big data, that is BD. We'll add another thing, that is artificial intelligence, that is AI. And last but not the least, we will be having a table. We'll be having a table. Sorry, total. Here, we'll be having a total. So let us add some values. 80, 70, total is 150. Machine learning, let's say 60, 40, 100. Deep learning is 40, 50, total is 90. Big data is 50, 70, total is 120. AI is 30, 10, 40, 40, and total is 260, 240, 500. So that is what we have over here. Right? Now, the contingency table shows that the number of female and males who joined specific program. For example, it says 70 females joined data science program. You can check this. 70 females joined data science program. And 40 males joined deep learning program. Right? Also notice that table shows the total in the last row and column respectively. So you have total 240 males and total you have 260 females, 260 male and 240 female. And so the total is 500. And finally, table also shows that total for specific program, that is 150 for DS, 100 for machine learning, and etc. and so on, right? So let us solve this question. You have to answer these questions now. 5 questions we have. First question is probability that a randomly selected person joined data science. Second question is probability that a randomly selected female joined DS. In other words, we can write down this as probability of a person joining DS given that she is female. Then we have question number 3, that is yeah. Suppose consider set containing all DL students. So we have one set in which we have all DL students and all male students, right? So you have to find this probability of A or B, like A or B, anything, which can be find out by using probability of A plus probability of B minus probability of A and B. This one, right? So you can find this set containing DL student is uh, meaning that you have to find probability of DL or male, this one. And the formula is this. So you can consider DL as set A, DL as set A, male as B, and you can use this formula, right? And question number 4 is probability of student being a female and an AI student, female and AI student. How can you do this is you can use this formula A and B because we have been asked A and B. So it is probability of A given B into probability of B, right? And I have another question, that is question number 5, which is probability of deep learning, probability of a deep learning student being a male, deep learning student being a male. So how can you do this? So you can consider again this formula, that probability of male given that deep learning student is probability of M and DL divided by probability of DL. This one. It's basically same as this condition. You have to use this formula on that. I think you guys can do this easily. Uh, if we have 5 questions, I'll give you 10 minutes of time. It's a 9:48. We can have break till 10 o'clock. And meanwhile, you can solve this as well. Yeah, you can try this out, everyone. All right, guys, is it done now? Have you guys solved these questions? The first question, probability that a randomly selected person joined data science. How can you solve this question? First question. So probability of randomly selected person join data science. It is 150 out of 500, right? 150 out of 500. So it is as simple as this, 150 out of 500. Now, second question, probability that randomly selected female joined data science. Now, here the condition is female, right? The condition is we are selecting female and she joins data science. We are going to select that. We have to find that. So probability of female joining data science is 70 out of 150. And that should be divided, that should be, or already we have this, no, total number of female are 240. And out of this total, 70 female have joined data science. So it becomes 70 out of 240. Simple. So that is 70 out of 240. Now third question. Third question is set containing all DL student, that is probability of DL or male. A or B is given by probability of A plus probability of B minus probability of A and B. Here it becomes probability of DL plus probability of male minus probability of DL and male. That is this, right? So using this table, what we can do is uh, table given in the description. This probability of DL. What is probability of DL? It is 90 out of 500, right? Probability of DL is 90 out of 500. Then probability of DL and male, that is this one, probability of DL and male, which is exactly equals to 40 out of 500. So I'll write down 40 out of 500. And last but not the least, that is probability of male. Probability of male is 260 out of 500. So probability of male is 260 out of 500. So we'll write on this now. The equation becomes probability of DL, that is 90 out of 500 plus 260 out of 500 minus 40 out of 500. That becomes 90 plus 260, 350 minus 40, that is 310 by 500, which becomes 62% or 0.62. Correct. Now, next question, that is, what is the probability of student being female and AI student? Student being female and AI student, AI. So we'll select this. And how do you calculate this? Is probability of A given B into probability of B. So you have probability of A and B. That is, okay, so probability of female given AI student, probability of female given AI student is 40 divided by 500, right? You can see this. Probability of female given AI student is, sorry, probability of female and AI student. or you can do probability of AI student, that is 40 out of 500. Therefore, probability of female and AI student, female and AI student is exactly becomes probability of female or AI student into probability of AI student, right? Considering this formula of probability of A and B, we have probability of A given B into probability of B. So probability of female and AI student becomes probability of female given AI student into probability of AI student. So your probability of female given AI student, right? Probability of AI student, that is female, is 10, right? 10 out of 40. 10 out of 40. So this particular formula becomes 10 out of 40 into probability of AI student. And what is your probability of AI student is 40 out of 500, right? So it becomes into 40 out of 500. And that becomes the, you can write on this is equals to 10 by 40 into 10 by 500, 0.005. So you can also do this directly from the table without the formula. Right? Direct, how do you find direct from the table? See, probability of female and AI student, probability of female and AI student, which exactly becomes this one, 3. Probability of female given AI student is 10 out of 500, simple. So it becomes 10 out of 500, right? Now question number 5 is probability of deep learning student being a male. Probability of deep learning student being a male. So probability of deep learning student being a male, it becomes 40, sorry, deep learning 40 out of 90. Simple. Deep learning student being a male, that is 40 out of 90. So that becomes 40 out of 90. You can do by formula as well, but I'll not show you formula. You can try this by using this formula, which is probability of male and DL into divided by probability of DL, and you will be able to solve this, right? So that was your simple uh, question and answer uh, that we have discussed for naive bias. Now I think we can go with the next part, that is your categorical data, for categorical data. So here we should understand naive bias for categorical data. We'll write on that. Naive Bayes for categorical data. Categorical data means you have string type of data. Categorical data means you have string type of data. So we'll now see naive Bayes classifier through an example of uh, we can solve this example, but it is very lengthy. Let's see. Having doubt in question number 4. Yeah. What is your doubt?
Uh, that will, so not that one. Can you come again down? Can you come down? Yeah. So this one, Q number 4, right?
Hmm.
So in line number 193, so you have kept a formula like 10 bars 40 cross. It's coming out around 0.5. So the same thing will happen in this below formula, right? So
Here.
10, but 10 divided by 500 will come around 0.2, right? So there's a difference.
Okay. See,
Why?
yeah. See, I think I've made a calculation error there, but
Oh, okay.
both will be same. Let's check it one more time. Probability of female given AI student. So female AI student. Female AI student. That is 10 by 40, right? 10 by 40. And probability of AI student. AI 40 by 500. 40 by 500. So do this now. 10 by 40 into 40 by 500, right?
Yeah.
0.00.
Oh,
So that was calculation error. Okay, we can do this, but it becomes theoretical again. So instead of this, we can do this categorical data by taking an example and again do the probability part, but you guys will not feel this as uh, interesting. Like we are continuously doing theoretical part, right? So instead of that, what we'll do is we'll just skip this as of now and we'll just move towards the practical implementation, right? So uh, this one that probably naive bias for categorical data, we'll just skip this as of now and we'll just discuss this after some time. So now we have naive bias for text data, and that is what important is for us, right? So what we'll do is we'll just highlight this, and text data means text classification. Like imagine you have given a bunch of statements, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you have to classify them into this as educational data, sports, right? News, or something like that. Then political, geographical, geopolitical, something like that. So how do you do this? By using naive bias. You have a text, and number of sentences will be there, and you convert that into categories, right? So how do you do this? We'll just see that. So naive bias for is predominantly used for text classification. Naive bias is used for text classification in applications such as predicting spam emails or classifying text into news, into categories such as politics, sports, lifestyle, etc. And in general, naive Bayes has proven to perform well in text classification applications. So whether it should be predicting email as spam or ham, whether it is predicting given classifying text news into different categories such as politics, sports, and life cycle. We do this thing. We use naive bias, right? So let's say we have a data set uh, wherein I have some sentences, like say, uh, GUI is a great educational institute, institution, right? I'll just expand this a little bit more. First is uh, educational greatness depends on ethics. Second is a story of great ethics and educational greatness. Third one is Sholay is a great cinema. And fourth one is good movie depends on good story. Good movie depends on good story. So the class is, you already have predicted this, but we as a human can easily predict this. But how we create a model so that our machine will classify into different classes, like first sentence is education, second sentence is also education, third is also education, fourth is cinema, and fifth is cinema. So we have to classify this into labels, right? So this document represents this class. This document represents this class. This document represents this class. So I should uh, create a model which will identify this, right? Now, how do you do this at the back end? What happens is you will create a vocabulary. I mean, you will not create, your Python will create that. But how it solves the problem is, we'll just see that. So dictionary before stop word removal. What is stop word? Let's say in our speech also, in our day-to-day conversation, or in our speech, if someone is giving speech, we use is, we use and, we use uh, of to just add to sentences, right? That is known as stop word, adding to sentences. And it can come n number of times, right? It can appear in your text n number of times. So this does not make any sense, like this does not have any meaning, right? So we can skip that. But for this test data set, my dictionary before stop word removal is this. So these are known as stop words, right? Which we use to fill two sentences. So I have this much and I have cinema. I'm just writing unique words, right? Depends, educational, ethics. So does not necessarily mean that you should sort this in alphabetical order, but I'm just sorting this in alphabetical order. Then greatness. Then here you have institution. Then you have ease. Then you have movie. Then you have off. You have on. You have Sholay, you have story, and you have GUI, right? So this is my dictionary before stop word removal. We have not removed the stop word, and this is my dictionary. This is what it looks like. And we'll remove the stop words now, which is and, is, off, on. We'll remove that, and we'll see the dictionary after stop word removal. We'll see that. So as I have mentioned over here, these are the stop words, and in these sentences, my stop words are and, is, off, on, and my dictionary after stop word removal becomes this. So 0 is equals to cinema, 1 is equals to depends, right? 2 is equals to. So I'll just copy this first of all. I think it is only 11. So I can copy this. I can paste it over here. And I can take this. 2 is equals to educational. 3 is ethics. 4th is good. Then great. Then greatness. Then institution. Movie. Sholay. Story. And Gooey. Right? So these are my unique words. Except after removal of. This is my dictionary after removal of stop words. Right? So that's what I have. Simple. Now, to summarize this, you understood the data you are going to be working with and convert the documents into dictionary vocabulary by removing stop words, which are not helpful for helping in document classification. And before we begin with next part, let us consider a document. So I have a document, the movie. Let's take uh, Padmavat. Is a great movie, a great example of beautiful cinematography, right? So based on the above information, you have to solve these questions. First, what are the stop words in this? Can you guys spot the stop words in this? In this sentence, what are the stop words that you have?
The is and yeah of.
Very good, very good. So these are the stop words. And could you just enter the number of words in the vocabulary after removing stop words? After removing stop words, total number of vocabulary or number of words. Yes,
6.
very
6
good.
was
6. And that is nothing but movie, Padmavat, great example, beautiful cinematography.
yes.
Yes, right? So that's what it is. Now, what happens is, what do we do is, so we have not only this much document, we have not only this document, we have n number of documents, right? But to just give you guys an idea how we use count vectorizer is, let's take this sentence. Hi, good morning. Hi, yeah, this morning I am feeling good. Uh, Morning I need a cup of coffee. Cup of coffee is what I need. So I have this sentences. Now we'll try to find the uh, unique words except stop words. So we have good, we have morning. In second sentence, we have this, we have morning. I am will not take that. Filling. Morning, it is there, so we should not consider this, right? We are taking unique words, no? So we have considered morning earlier, so we'll not consider second morning over here. Then third is morning. I need, so I'll take need. Cup of will not take, and we'll take coffee. And then we have cup of coffee. Cup of coffee is what I need. So cup of will not take. Coffee will take. What will take. And need is already there. So need also will not take. So I in this vocabulary, I have only this much unique words, right? I only have this much unique words. So now what we do is we find the frequency. So suppose the word is present over there in this sentence, I'll write down one. If it is not present, I'll write down zero. We write down zero. So good is present, yes. Morning is present, yes. This, no, 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 zero. This morning, so it will be zero. Morning is one. This is one. Filling is one. Need is not there. Zero, 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 zero. What about third sentence? Zero, one, zero, zero, one, 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 zero. And it will be one, 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 one. Need cup coffee. And this will be zero, 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 zero. Simple. So that is how your machine learning will convert your text kind of data into numbers, right? That is what your model will be doing this. And how we do this? We make a use of count vectorizer. So your count vectorizer will be a correct, or will be using this count vectorizer to solve or to convert text into numbers, right? So we just have to import this package of count vectorizer and we solve. We convert that into numbers. We convert this vector into an array of numbers and we solve this, right? So that is known as bag of words, or that is known as count vectorizer. Now what we will do is we will just take a data and we'll start working on that data. It's very simple. So you guys have understood like what and how we proceed further with the what happens in the background, how it converts into numbers, and then how we feed it to the data. We'll see that by seeing the coding. So on your drive itself, on your drive, on your drive, what I'll do is I will create a folder, create a folder for today, which is day number 23, day 23, new folder for day 23. And we'll just write down the 22nd December 2024. Simple. And we are interested to create, upload the file for knife bias. So the file data that we have is SMS spam collection. Yeah, this one. Okay. Now, what we will do is we'll just create a new, not form. We'll create new Google Colab here. I think I should close multiple tabs. We should rename this as naive bias on SMS data. So you can start working on this simultaneously with me, or you can just have a look at what we are doing. But I'll suggest to do this simultaneously so that your first round of practice will be completed, right? So you can create your new collab notebook. Now we'll just upload the data. This is my data. I'll open this, right? And let us start importing the necessary libraries. Data handling and manipulation libraries will import pandas as PD, import numpy as np. We'll add on data pre-processing libraries from sklearn dot pre-processing. We import label encoder. We can do one hot encoding. We can do encoding as well. Then we'll write on count vectorizer library. So suppose if you don't know how do we import the count vectorizer, we'll go to you'll write on count vectorizer, and you'll write down sklearn official documentation, right? So that is what we have. I'll just copy this. I'll just copy this, and I'm going to paste it over here. Then I'll write on from sklearn dot model underscore selection. I'm going to import train underscore test underscore split, and I'll write on from sklearn dot naive bias. I'm going to import multinomial naive bias. What is multinomial naive bias? It is one of the types of naive bias. We also will also discuss this different types of naive bias because we have not completed naive bias module, right? So I'll discuss that as well. And then we have to use evaluation metrics. That is your R accuracy, because this is a classification model. So you can write down accuracy score, precision recall, F1 score. Perfect. Now, this data is having extension. It's not CSV, it is not Excel. So if you just write down df is equals to pd dot read underscore Excel, and if you just copy this path, it will not load that. You'll get the error, right? You'll get the error because this file is not Excel file. This is not even CSV file, right? So what is that file is all about? It is your tabular data. So it is table, pd.read underscore table. And we write down names. Okay, so if I just write down pd.read underscore table, I'll be able to read the file, and I'll just load the data by using df.head. And this is my data wherein I have particular email is spam or ham, and this particular email over there. But one of the problems over here is this particular thing is not my heading, right? This is not my heading. So what we should do for this? This is not a heading. This is part of data only, but it is misplaced at the first location and considered as the heading. So what I'll do is I'll write down names is equals to label, comma, message. right? So these are the names of my column. First is label, second is message. So if I just run this, if I just run that, df.head sale, I'll be able to rename my columns into label and message, right? Now, what is my problem statement over here? The problem statement is based on the message, you have to categorize the data into spam or ham, right? So you have to categorize the data into spam or ham, and you have to create a model. So just like analogous to your Gmail, how it converts a particular message into spam, junk, or uh, not a spam, is uh, they obviously don't go with the very basic approach, because this is machine learning approach. Nobody uses machine learning approach to classify mail into ham and spam nowadays, because we have got there have been n number of advanced techniques available. So we make use of word to vec model, which you guys will be learning in NLP part. And you see, Google is very, it's a team of very excellent people, right? Excellent, smart people out there. Uh, for an example, they build a model with such a precision level that the moment that uh, if something is come appearing in your email, let's say Delhi, it will understand that it is from India, right? So it is, it should be very, what we can say, very fast, very uh, accurate. So they will make use of their own model, and their performance should be very impressive, right? So I have just given an introduction about this NLP kind of thing, wherein you guys can go and explore word to vec, what is word to vec, so that it will help you understand whenever we are going to start NLP model, right? So if you just write on word to vec, if you just write on that, uh, I'll suggest to go for simple kind of video, not to go in much details about that. So as of now, at this point of time, I'll just go for this code basics. Even though this is very legitimate resource that we have. So if you feel comfortable with Stats Quest, I'll go with that. I'll suggest you to go with that. Or if you are not comfortable with the advanced part, you can go and explore the Indian channel, right? All right. Now let us focus on our topic, which is our knife bias. So I'll write down df.head, which we already have discussed. I have label and this is my message. And if you just read this, you'll understand what this message is all about. Suppose let's take first example. Go until Jurong Point, crazy, available only for this. So obviously this is not a spam. But what about this free entry in a 2 weekly competition to win FA Cup final? The moment if I read this message, free entry in a 2 weekly competition, you guys will understand that this is spam, right? So obviously it's a spam. Now what we'll do is, for label, we'll find out value counts. Open close bracket. We'll find out value counts. And okay, label spelling is small. L is small. Now L is equals to, we'll import a package, label encoder, open and close this one. And I'll write on df of label is equals to le dot fit underscore transform. I'll do transformation on label column, and I'll just check head of the data that I have now. So what is this label encoder? It is nothing but just converting your ham and spam into numbers, that is 0 and 1. So it's an encoder, just like your one hot encoder, we have label encoder. And the procedure to convert the your label into zeros and one is by using fit underscore transform, right? Nothing special about that. Now what I'll do is, in order to understand count vectorizer, we'll take a message, just random message. So I'll write on hi, I have reached home. We are just creating a corpus or a vocabulary, a dummy vocabulary of our own, and we are trying to fit the count vectorizer on that. So you have won a lottery of 1 lakh rupees. How are you, comma, good morning, comma, hi, this is Vipul from ML batch, comma, congratulations, you have won a lottery, and comma, good morning, morning, right? And I'll just close this with the bracket. Now we already have seen this in Excel over here, so you guys have already been familiar with how count vectorizer work. Now we'll see it in Python, like how to fit count vectorizer. So this is our message. We will create an object of CV, which is exactly equals to my count vectorizer, open and close bracket. I'll write on CV.fit, fit it on message, and I'll write on CV.get underscore feature names, open and close bracket. And okay, that's not good, feature names. Words equals to CV dot get underscore feature underscore names. That is correct. It's not there. Just a minute. Get feature names. Okay. Get underscore feature underscore names. Yeah, we have done this only, no? To newer version, it is already there. Okay. Okay. Let us try restart and run all first. This is very common error, which you guys will be having if you do it in feature names or features name. What has no attribute feature name? If I just take this, okay, no issues. What we'll do is we'll try doing this over here. We'll create new notebook, new folder for knife bias.
Hey,
And
Vipul, can you try that get feature underscore name underscore route? So, I think that is working.
yeah,
Underscore
but
route. Hmm.
yeah, we have read this. Oh, here it is saying it is out of.
Okay. For me, it's working. So
Is it working for you?
yeah, yes.
So just what is that? Kate underscore feature underscore names
Names.
underscore out. Okay, fine. But let us try one more thing. What we'll do is we'll just quickly upload data and we'll just try to read the same file, this one. Let us upload the data for naive bias, because I'm sure this we have this attribute of gate underscore feature underscore names, and I have to check if it has become obsolete or not. That's why I'm just taking this in Jupyter Notebook. And in official documentation itself also, they have given this, no? See, in official documentation of sklearn for count vectorizer, we have a parameter called feature names, this one. So we'll just check this. Here it should be this. And we should restart and run on this. Can you see this? Now it is working. Here it is working. It was not working over there. Anyway, no issues. What now we'll do is we'll create, if you just check words, it has converted the unique words, right? But data type is object. Still, we have a vocabulary of unique words, but it is not converted into an array, right? We have to convert that into array so that we can feed this to our machine learning model. So I'll write a matrix is equals to cv.transform. I want to transform what? This message, this one, into array. So I'll write on this. So I have a matrix in which I have an array of 0, 1, 0, 1 like that. So what is this? This is nothing but this thing. This is nothing but this thing, right? So we have two separate things. We have an array of numbers. 1 represents the number is present in that sentence. 0 represents the number is not present in that sentence. And we have the words, unique words. So we have two part, right? Words and matrix. But in machine learning or in anything, in computer, if we have to feed this to our system, we should not have these two separate entities, right? We should have one entire entities in which we can have a data frame, just like this, a single entity in which we have unique words and matrix. So we'll convert this into data frame now, because it is two separate entities, but we have to convert this into data frame. So I'll write on def underscore example, data frame name. And you guys already know how do you convert into data frame, which is pd.data frame. The data will consider it as matrix and columns for my data frame equals to words. So consider this as a data frame in which the column names are words and the data, this data is your matrix, right? So we'll convert that. And if you write on def underscore example dot head, you'll be able to get the head of the data. Basically, this thing only, this table, right? So now we don't have a separate entity, separate two entities. We have a single entity and we can start working on this particular problem. So this is how you fit count vectorizer on a data. Now let us move further with our original data that we have for spam and ham. So I'll give a heading as count vectorizer implementation on SMS data. We'll check the info of the data that we have. We'll create an object for count vectorizer. vectorizer, open and close bracket. I'll write on x is equals to df of message. I'll write on y is equals to df of label. Same thing, we'll fit it on x. So I'll be having unique words, unique underscore words is equals to cv dot get underscore feature underscore names. Now we need to write down out right here because it will throw the error. So we should write out. Right? And we'll write on count is equals to cv dot transform. Same thing, we have to transform x into array, which we have done right earlier. Now, if you just find length of unique words, how many unique words do you have? How many unique words? How much unique words you have? You have 8713 unique words. Now it's time to convert this into data frame. We'll write down df underscore message is equals to pd dot data frame. Data is count. Columns are unique words, right? Data is count. Columns are unique words. And if I just write down df of message, I have converted into, or if I just write down df of message dot head, we have a data frame in which we have unique words and we have the matrix. And now all the things will be same, where we generally do extend. We will be performing train test split. Train test split. We'll add on x underscore train, x underscore test, y underscore train, y underscore test is equals to package name train underscore test underscore split. I think we have not imported this package. Let us check. We need to import that. Is it there? Oh, it's there. Okay. So this is our package. In that we pass x, that is my df underscore message. Y is y. Test size you can take anything. I'll take 0.3. Random state also you can take anything. I'll write down 3. Or let's take 42. Anything is fine. And we'll fit multinomial naive bias. So object creation. You guys know, right, how to fit the machine learning model. Step number 1 is object creation. Create an object. We'll write down naive bias is equals to the multinomial naive bias. Second step is, what do we do is, we fit the model. So naive bias dot fit. We always fit it on x10 and y10, right? So I'll just write down over here. We fit it on x10 and y10. Remember, always we fit it on x10 and y10. Now it's time to go for step number 3. That is your prediction, model prediction. So we'll write down an y underscore pred is equals to nb dot predict. We use x underscore test for that. So remember, we use x underscore test to predict the y always. And what is your step number 4? X small x. Because here we have defined small x. And what is your step number 4? What's your step number 4? Model evaluation. So we'll find accuracy score. Accuracy score of y test and y pred. So we'll read different types of model in naive bias. We'll be reading different types of model in naive bias cross validation on the above model can be done, but that is something which we have not discussed, cross validation, so we'll not be doing that. Once we discuss cross validation, we will be you can do this cross validation on this model to increase the accuracy further, right? Okay, so that's what we have. Now if you have any questions, if you have any doubts, you can ask in this module. Yes, guys, do you have any questions?
Fitting the model and prediction evaluation, these steps continuously we are using for all the data, right? For model, we have to follow these steps.
Right, I told you, right?
The same for all the models.
It is same and common for all the models out there. Yes.
Okay.
So the accuracy for this model is 98.5, right? Now you can go through this. I'll give you 5 minutes of time. If you have any questions, you can ask. Otherwise, you guys will be having a quiz.
Am I audible to everyone? Hello?
It's audible.
Okay. So, can I have Kahoot
Yes, yes, we can have quiz now.
now?
All right, guys. Do you have any questions now? If you have any questions, we can discuss. Otherwise, we'll just stop here for the day. And in the next session, we'll continue with the more discussion on knife bias, right? चलो ठीक है. If you don't have any questions, we can stop. All right. Thank you, everyone. Bye. Happy learning.